In this section, we take a look at how two lines can interact with each other. And those two lines together form a system of equations. So for example, two lines can intersect in exactly one spot. And that one spot that they intersect in is called the solution. Another way that two lines can interact would be if they were parallel to each other. In other words, we have one line with the same slope, but with a different y-intercept. In which case they have no points in common or no solution. Whereas this one had a point, just some xy point in common. The last way that they can interact is if one line actually sits on top of another line. And in fact, all you would see is just one line. But they would have a lot of different points in common. All of these points would be common solutions. So those are the three different ways that two lines can interact with each other. When they don't have any point in common and we say it has no solution, we call that an inconsistent system. And if they do have solution or solutions, then we call it a consistent system. This is just labels for these two different categories of lines. If it's a consistent system and we see two separate lines, or it has one exact solution, then we say that this is also an independent system. Whereas if there's many solutions, but we only see one line depends on the other one, we call this one a dependent system. If it's inconsistent, we don't worry about labeling it independent or dependent. That's only if it's a consistent system. In this section, we're going to be looking at, can we find a solution, or is it dependent? In other words, it has many solutions, or does the system have no solution, where the two lines parallel to each other? So let's take a look at a system of equations and then try to determine what type it is. So for example, if I start out with a system that's like this. This is a system of equations, and I can solve this in a couple of different ways, but I'm going to focus on solving by the elimination method. To do that, the elimination method says if I add the two equations and one of the variables drops out, I can solve for the remaining variable. In this case, if I add the two equations together, notice that the y terms are going to cancel out. Plus y minus y cancels out to 0. For my x's, I have 2x plus 1x equals 6. Solve for x. So I have x equals 2. But that's the part of the point, the x coordinate. I still need to solve and find the y value of this point. So what I do is a method called back substitution. I take my value of x and I plug it back into either of the two equations for x. It doesn't matter which one. They're going to have the point in common. The point will be on both lines. So I just put it in the top equation. 2 times 2 plus y equals 5. 4 plus y equals 5. Solve for y. And I get y equals 1. So that's going to be the point 2, 1 that happens to occur on both lines. And you can check this by taking the point x equals 2, y equals 1, and plugging it in. So I'm going to get 4 plus 1 is 5. But this should also fit in the bottom equation. X is 2, y is 1, 2 minus 1 equals 1. So this is my solution, which means these two lines, if I were to draw them up, cross exactly at the point 2, 1.